Hey guys, welcome back to the channel. Do not mind the earbuds. All right, we're just, music's on, we're grinding. So we are working on our UCC deck plate. You guys saw the overview video. Now it is time for the nitty gritty. A lot of you guys are always curious on the measurements and stuff. So what I do to establish my piston wall is Diamond actually gives you where to measure 90 degree from the pin center line down the bottom of the O-ring groove. So once you get that set up, what you do is you will get your inside mic zeroed like so, and then there you zero it on your dial bore gauge, which I've already done all this, so I apologize. And then you go ahead and you realistically, because it's a new block, you want to, you know, just verify the machine work. I've actually never had to measure a no limit block before. When Todd first built his engine, I didn't even work there, so I just, again, just want to double check Eric's work. So far it is spot on to what I want on the piston wall. And then we're going to grind our piston rings. For those of you guys that are new, this is the tool that I use here. This is a Total Seal ring grinder. It is branded as the Summit. If you are in the market, the Summit brand and the Total Seal are probably made in the same factory in China. Actually, correction, made in America. This is pretty much a necessity for Total Seal rings, in my opinion. You can use the manual grinder, but you will be there all day, especially given how much you have to machine off the rings. So this allows you to zero the dial bore gauge, and then let's say my ring gap's at 10 and I want it at 20. Well, I zero it here, I go to 10 thousandths on the indicator here, and I've found if you apply the pressure straight down, it's kind of intermittent. On that last pass, just apply ever so slightly a little bit of down and in pressure, and it seems to be spot on with the 10 thousandths or just any increment there. So again, you can go like this, small strokes. You'll hear the machine kind of what's the word, you'll kind of hear the load start to change, and then you kind of go in a little bit like so. You guys see how that moved on this knob here? So you'll go there, and then on that last pass, just a little bit of inside pressure, and you're good to go. Grind your burrs down on this. This is a game changer. But on these Total Seal rings, the reason why I never film this is because essentially you have to grind the top ring, the second big ring, the part that makes a gapless second ring, and then this you do not grind, but you do have to grind both oil rings. So for an engine build, you have 1, 2, 3, 4, 5 rings to grind, as opposed to your regular Cummins stuff. I've never actually had to grind an oil ring, I'll be 100% honest. So usually on the bigger cast piston stuff, my second ring's dropping in at 40 plus, so I leave it alone. My oil rings are dropping in 15 or so, leave them alone. The only ring I usually have to grind is the top ring. Sometimes you get lucky and it's like spot on too. But on the Total Seal stuff, you guys will see here, I'll drop this top ring in for you guys. And I have a piston squaring tool, but for the sake of keeping this a little bit shorter, we'll drop this sucker in here. If you guys look at how tight of a gap that is, like, we're gonna have to open that up quite a bit. Just looking at that, that's probably, maybe 10 thou, and we're gonna easily double that. So it takes a while. And all of the rings are like that, I found, with the Total Seals. So not a stab at them, they make a great ring, just a little bit heavier on the installation side. So what I'm going to do, spare you guys all the dramatics, I'm going to get all of our piston rings ground up. From there we have our crankshaft. As I told you, I actually got it out of the package. Meyer machined this down. This one kind of had some chattering on the front, and I told him to kind of leave it a little bit rougher. It's true on a lathe, but it's got a little grit. I'm hoping between that and the diamond washer, we just get like just a great tight fit on here. But anyway, with our crank here, we can also go ahead and put our rod bearings in our rods, torque those down, and check our rod bearing clearance, as well as get our main bearings put in the engine block, torque that girdle down, and get our main bearing clearance. So I'm gonna skip all of the measuring stuff. If you guys go back to like March, April time of 2021, I did an entire video on how you measure these blocks. I encourage you, if you're new or you want to learn or you want to double check, I went through every measurement: piston, pin clearance, like this clearance on the piston to wall, ring gap, all that stuff is covered there. I'm going to skip all that, get all of this done, and then I will show you guys as we put the short block together what she looks like. This is exactly why you don't wash the block before you do all your measurements, guys. We got all of our piston rings ground. It took about 2.5 hours. I'll be honest, if I did it more often, I'd be a lot faster, but I rather would err on the side of taking longer than making a mistake, especially with these rings, because they're just, I mean, they're not super hard to get, but they are kind of expensive. So we got all of our ring gaps ground down. We're going to call it a night for tonight. Tomorrow we will measure our rods and mains for oil clearance. After about 12 hours, we have checked our bearing clearance. You guys can see here all of our witness marks. We got our girdle instructions, which, guys, this is there's a lot of steps here on this cross bolt. What is that? 60 bolts that you got to torque in different areas. We got our block prepped, our cam bearings checked. We did get our rods done as well, and our pins, and our pins in the pistons, pins in the rods, all of our bearing clearance checked. We are ready to go. Now, since I just filled this block full of itself with the Dremel tool, we're gonna go ahead, clean it up, and then we could start dropping the parts in there. I also have to weld the crank gear, but short block assembly will begin. For those of you guys that wonder, like, oh, it's not that bad, the engine procedure and stuff, like, half the reason why engines are so expensive and you're getting them from a reputable shop is because we take the time to dial bore gauge your piston wall, dial bore gauge your bearing clearance, your rod clearance, your piston pin clearance, your ring gaps. Just the rings alone took me 3 hours on a set of total seals. So again, like, when you guys are buying these engines, like, I saw a thing on Fire Punk today about, oh, how much should I pay? Guys were saying $4,500, stuff like that. Like, if you're getting a built bottom end and like a ported head and stuff, like, those motors are not cheap. $14,000-$15,000 for one of our Ultimate 6.7s is about the asking price on them, and it's because we take so much time cleaning it, measuring it, checking it, file fitting rings. Like, if you guys throw these things together with this stuff the way it comes out of the boxes, it's never gonna live. Like, you flip-flop bearings around, like, some of these are H's, some of these are HX. That way we get the proper rod or bearing clearance here. Same thing on the rods, some are H's, some are HX's, and you flip all this stuff around. That's what takes so long. On these, with the Foley bush cam, we got to go through and check all of the oil clearance that now the bushing might be blocking. So all that stuff takes time. We have cleaned our engine block. I kind of tidied up in here. A lot of this stuff is going to go away once we start bolting on the engine, so rather than try to reorganize it and move it, but yeah, and this is just wrapper from that oil pump, so don't lose your minds. But we got the block cleaned. You guys can tell by the nice little glisten to her. She has been lubed up with a little WD-40. I spray the big areas, and then I take a microfiber, wipe all the nooks and crannies out. You guys can see the WD right there. But yeah, got that done. Again, when I lived in Utah, you could really leave a block wet for quite a while. Now that I live in Virginia, you know, these things will flash rust in a few minutes if you're not careful, especially on like a humid day. So soap and water, compressed air, and then I use brake cleaner to disperse the last little bit of moisture. From there, we WD-40 it, and it is now considered clean enough to be in the clean room. I know it looks very crowded, because it is, Got the O7's intercooler radiator over there, got a cam. But again, most of all of these parts will go in this short block, and it'll declutter this area quite a bit. But let me get to the next project, and then we can start assembly. Is going to be TIG welding this crank gear, and obviously I got to clean the main caps off as well, which is why they're still sitting out here. I'll clean those off and get them ready for reinstallation. If you're ever curious what it's like building engines, very tedious. You do a lot of things many times, cleaning each time, and to me it makes it all worth it when either I or a customer hits their goals. So I'm gonna get this welded up on the common rails. What I tend to do is I will do 3 welds about 1 inch long, and I try to evenly space them. I've seen people argue about throwing a crank off balance, yada yada. You know, I'll be honest, guys, with how much filler rod you use versus how much fusion weld you use, given the center line, I mean, maybe if you started welding out here I could see it, but I mean, you're talking about 1 inch off center line. Either way, we'll be fine. My bad, totally had this cool video to show you guys this, but no dice. Check out Meyer's sweet lathe mod he did there. So it's not a big deal. We're gonna put a wear sleeve on it, but we got our 3 welds here. 1, 2, 3. We got our dowel pin for the fluid dampener, the factory pin put in. Now it's time to clean this crankshaft. Soap, water, brake clean, WD-40 compressed air, and then this can move back into the clean room and we can put it in the short block. Okay, so you know how I've been telling you guys the camera keeps dying? I don't know what is going on, but I just ordered a new GoPro. It keeps hitting this thermal limit, and it literally just sits right here. So I'm not sure. I do apologize. Even my dad, who watches my channel, is like, man, like, camera cuts off and all of a sudden all this work gets done. So I don't mean to be like that, but you guys saw us. I think I caught it in time. Basically, what you do on this no limit girdle is you install the lower bearings. Obviously, you guys saw us put the lifters in. You guys saw me put the J-Jets in, a little bit of blue Loctite, then looped up the bearings, dropped the bearings in, dropped the crankshaft in, then I put the main caps in, and per the instructions, it says to tap the main caps in, start these side bolts here in about halfway, then we torque all of our main studs down in a torque sequence to 100 foot-pounds. Because this girdle actually grabs the rear main housing and the front housing, what I decided to do is put these on. So we got a wear sleeve on, rear main here. We then put our front cover on, RTV gasket, and then I do these bolts. This is just to keep an even clamp force. These will come out, obviously, when I go to put the cover on, but it keeps the clamp force even. We got our stuff cut here. Now, what the instructions say to do is loosen up all the nuts, take them off. Then we'll have to go make sure our studs are bottomed out and then turn them back. Then we can slide the girdle plate on and then start the torque sequence again. But we did get our cam in, torqued, front cover torqued, and you know, always give your cam a good twisty twist or crank. And you guys can see here, this cam again is reused from our old UCC engine, as well as the lifters, TIG welded. And then I had a guy ask if I've ever been able to get these off. Yeah, all you do is you basically cut a line here and almost essentially kind of like grind the weld off. And then you can pop the gear off. I've never had an issue getting them off. Usually I sell them or they blow up, so I don't ever have to worry about it, but I have gotten them off a few times. The crankshaft is a little tougher. I don't actually have a press here, but Steve has a press. At PDD we had a press, so it's not hard to get them off. We did check our camshaft as well. On the intake center line when I installed it the first time, so we know it is in fact correct. Again, I will verify it one more time, but as far as the offset keyway goes, I'm pretty sure we're set up and we got it all timed. Now I'm gonna go ahead and take all these off, clean all the caps, re-lube all the studs, re-lube all the hardware, and then I'll set you guys up on a time lapse when I go to bolt the girdle down. Have our crank in here. You guys saw that torque spec, so it's start all the bolts, set the thing on, and then start the cross bolts, start all these bolts, torque the main studs down, then you torque the cross bolts in, then you torque the inner pan rail, then you torque the outer pan rail. So now that that is done, we can do our pistons. I'm gonna do a little bit of cleanup here, and then get everything set up, rings on, everything cleaned up, ready to go. And then I will click the camera back on and we will flunk these in real quick. And yeah, that should be probably a wrap on the video, but let's get this short block done up. Our pistons, rings, and rods are assembled. I'll set the ring gap specs ring spacing once I get them covered in oil. Blocks oiled, cleaned, ready to go. Get a GoPro set up for you guys. Let's thump these in. There she is. I know what you guys are thinking. That was actually diamond. I needed this set of pistons a long time ago really quick, and only one had not been coated when I changed the valve relief. So that's why we got 5 in 1. But crank thrust, cam thrust checks out, protrusion checks out. Protrusion on this is a little different because this ring is standing up past the block. So what you do is you zero your gauge here on the deck plate, slide it over, and you get the reading there. That allows you to basically not use this sleeve here as part of the equation, because normally you would basically either the fire ring or the head gasket takes up this space. So just pretend like it's not there. Very easy to do. Now I'm going to go ahead and get this thing taped up and primed, and then we'll do the color review. So the next time you guys see this, it'll be all painted. There she be, black pearl metallic. It's still drying right now, but we got it all sealed up. This is how it'll sit until our cylinder head from industrial injection gets here. And then from there, again, there's our King Speed shelf that we got to throw on the head. It's already cut for it though, so it shouldn't be too bad. And then slap the head on this, torque it down. Very, very easy from here. Really, the hardest part of any engine build is the measuring and cleaning portion. After that, they really just go together pretty quick, as you guys saw in the video. I do apologize for the GoPro difficulties. I have got something ordered for that, so hopefully we don't have any more huge jumps of time where I'm working and don't realize it's not recording. And yeah, this, you know, guys, hopefully is the answer for our quest for 3,000. I really hope it is. Hope you guys like this one. Drop a comment down below. Subscribe if you are not already. And as always, guys, I'll catch y'all on the next one.